In this video, we're going to look at an acceleration problem where we solve for acceleration, but where an object is slowing down. So we're going to use our standard acceleration formula. Acceleration equals final velocity minus initial velocity divided by the time. The problem we're going to look at is a car traveling at 50 kilometers per hour. When the brakes are applied, it slows to a stop in 6 seconds. What is the acceleration of the car? So we're going to start again by listing everything we know. So we have 50 kilometers an hour. That's our initial velocity. It's initially traveling in the east direction. We have slows to a stop. So a stop implies to us that the final velocity is 0 kilometers per hour, and we'll make that also in the east direction. And then lastly, the time of braking. So it's going to take 6 seconds for this car to come to a complete stop. So we have enough information now to solve, but we need to do some unit conversions. So the first thing we're going to do is solve for the change in velocity. So VF minus VI, which is 0 kilometers per hour east minus 50 kilometers per hour east. So our change in velocity is negative 50 kilometers per hour in the east direction. Now we need to convert this into meters per second. So we're going to do that now. We're going to take 50, so negative 50 kilometers per hour times, first thing we're going to change the kilometers into meters. So we know there's 1,000 meters in 1 kilometer. That will allow us to cancel out kilometers. We're left with now meters per hour. And then we're going to change from from hours. So we know that 1 hour is 3,600 seconds. And that will allow us to cancel out those hours. And we're left with meters per second. And we get 13.9, so 13.8 repeating meters per second. So that's our change in velocity. So now we can plug this into our acceleration formula. So acceleration is change in velocity over time. So negative 13.9 meters per second in the east direction over 6.0 seconds. And we get negative 2.3 meters per second squared in the east direction. We can also write this as 2.3 meters per second squared in the west direction. These mean the same thing. And the reason for that, if we think about our compass, so if we have our normal typical compass, north, south, east, west, if something is traveling east, or something starts east and begins to slow, so it has a negative east movement, it's technically going towards kind of the center of the compass. So this would be considered a negative direction, negative east. However, if you look, this arrow is also just traveling west. And so either would be acceptable.